Welcome everyone. This is Jim Chastain with EasyPower, and I want to welcome you to the EasyPower webinar series. Before I introduce our guest speaker for today, as we are wont to do, I'd like to run a series of poll questions, and invite you to participate. There's obviously no obligation, but it helps focus the discussion as we get into this. So with that in mind, let me kind of jump into the poll questions. And first question is, are you aware of the public comments and NFPA 70E website? So if you would please indicate accordingly. We do appreciate your attendance today, and because there's an international flavor to this discussion, there may be some trick questions on my list, so don't be offended. So it looks like we have a quorum on this session. So here's how people have weighed in on this one. And then the next one, how well do you understand the differences between 70E and Z462? Let's see how you do here. And I'm sure I fall into the latter category. I think many of us are kind of hunkered down behind the domestic firewall. So seems to be that we get higher attendance, which we would hope for. One side comment as I close out this one and share it, we do provide attendance certificate for those of you that are using that for your EAU justification. So again, we appreciate your joining us. All right. And then our third question is, do you currently include an HRC category or a CAT category on your ArcFlash report? And there's not a right or wrong answer, so that's why it's more of an opinion poll, but hopefully this will foreshadow some of the details that we'll get into during the discussion. So it looks like we got close to a quorum on this. Here's where people have weighed in. And then the fourth question, has your company been overwhelmed by all the changes going on? You're not in the minority in this case, if you are. I like Terry's presentations because he comes up with some good poll questions. So it looks like we have a quorum here. And here's where people weighed in on this one. Thank you. And then the zinger. So are you aware of IEEE 1584.1? It looks like we have about half the, we got a quorum, so that's cool. Excellent. Well, again, thank you for joining us today. Our guest speaker is Mr. Terry Becker. He's a professional engineer and a voting member of CSA Z462, CSA Z463, and the IEEE 1584 technical committees, as well as 1584.1 subcommittee. So with that, let me hand the podium over to Terry. And Terry, it's all yours.
Thanks, Jim. Appreciate that introduction. And those poll questions were obviously strategic to some of the content that I'm going to present today. So I just want to welcome everybody and thank you for attending this webinar. I also want to just take the opportunity right now to thank EasyPower for allowing me to present today, and specifically Jim for being our moderator. So again, we're going to cover off today this understanding the differences between 70E and Z462, including what I said is a peek into the 2021 editions. And I'm based out of Calgary, Alberta, Canada, and I do all of my electrical safety consulting predominantly here. So I think there's a good blend here if we have a lot of attendees from the US and hopefully some contingents from Canada. And I believe Jim said we've got some international attendees as well. So I'm going to sort of give you the perspective and make at least the Canadians more aware of Z462 and its relationship to 70E, and then the poll questions that Jim brought up. So I'm not going to go through the introduction again. Thank you, Jim, for basically letting everybody know, but I do want to just repeat that I am a voting member on the CSA Z462 Tech Committee. I'm one of the founding members. I've been there since the beginning back in 2006. I am the first past vice chair. I'm a voting member, and I'm in charge of the working groups for Clause 4.1 and the annexes. And again, that is one of the differences between 70E and Z462 is they're structurally based on NFPA and CSA's format. So articles in 70E and clauses in Z462, and I'm going to try and bridge some of that information as I go through this webinar. Again, my background's all electrical safety consulting, 28 years as an electrical engineer, but 12 years doing electrical safety consulting and really interpreting these standards and helping companies understand how they can use them as due diligence to H&S regulations, but ultimately so that when we have workers performing energized work, we either eliminate exposure or we use the hierarchy of risk control methods and then the policies and practices and procedural requirements in 70E and Z462 to reduce risk to as low as reasonably practical when, again, we have workers performing energized electrical work tasks. So just a standard disclaimer that you'll see from presenters like myself that the information I'm presenting today is my personal interpretation and opinion of NFPA 70E, Z462, IEEE 1584, IEEE 1584.1, or any, the context of my comments. This presentation is not affiliated with NFPA or the CSA group, again, and I'm not going to review all potential changes. And these changes actually, when you'll learn today, are actually available to the public related to NFPA 70E, the 2021 edition on NFPA's website. And again, that was one of the things I wanted to educate everybody today about, is that this process of developing 70E and Z462 is a public process. So here's the agenda that I'm going to cover. Just a brief introduction, talk about technical harmonization between 70E and Z462, review at a very high level the 70E Tech Committee and the process that NFPA uses, again, the public input process, cross-correlate that to the CSA group's process, briefly discuss that. Then I'm going to take a sidebar a little bit and talk about interpretation and application, and that relates to some of those poll questions. Again, we've got two standards here, NFPA 70 and Z462, and then separately what's been happening for arc flash, and it's not been happening, it's actually what we need to have happen, is we've had calculations performed using the IEEE 1584 standard, first published in 2002, for 2.8 volt to 15 kV electrical equipment. And then the poll question was obviously what I expected, is not too many people understand that there's actually a complementary guide, IEEE 1584.1. So I'll just briefly review that later on in the slides. Then I'm going to highlight some of the public comments, second revision changes we might see. Again, these are expected changes. The processes are in play right now. Then the new version of 70 for 2021 has not been finalized, has not been approved yet. It will be following the remainder of the process that's used, and then you'll see it published. Probably, I think we've seen it historically September, October of the fall before the actual published year of the standard and the title. CSA Z462, just quickly, it will be planned to be published in the beginning of 2021, and that's just traditionally what we've done with the publishing of the new version of Z462. And then I'm just going to do a quick cross correlation of some of the key differences between Z462 and 70E and what we expect for changes there. Then some conclusion slides, and then we'll have some questions at the end, and we'll try and address the questions if we can. We'll see how much time we have, and I'm going to try and make sure that I do stay to some timelines here so that we have questions at the end. So I wanted to start by introducing 70E and going sort of back in history a little bit. The public may not be aware, and when I say the public, all of us, right? And I was not aware of these processes till basically 15 years ago. So the 70E first published back in 1979. It's a pretty mature standard, but the context of it has changed substantially since its first edition. It focused on installations, and there's a bridge and some background information here with respect to the Occupational Safety Health Administration in the US, and they had a requirement because there was injuries happening due to shock, and then what happened as this standard evolved, arc flash was added. So really it's the shock hazard and the arc flash hazard that 70E evolved to address. So in 79, the first edition published, and it was originally titled Standard for Electrical Safety Requirements for Employee Workplaces. It was republished with additions and changes and then refocused, and that's where more of the arc flash content was added and the safe installations content removed because it was repetitive to the National Electrical Code. And then really additional editions published, and then in 2021, if I did the count right, it's going to be the 12th edition of NFPA 70E. So very mature, lots of changes and additions and evolution. And today I'm just going to give you some insight on where the latest edition is going from the 2018 edition. The good news, the last bullet on the slide, is this 2021 edition of 70E and CSA Z462 will not include substantial technical changes. Slowing down. Thus, one of the poll questions: are you confused with the amount of change? And industry has been confused and, I guess concerned, and that this changing, every 4 years has been a lot of technical changes and content changes. Good news, slowing down. You're going to see a lot of cleanup, a reorganization of the content, and the gem of the new 70E is going to be electrical hazard information related to capacitors. And again, this is what happens with the standard. It keeps changing, it keeps improving, and this, in my opinion, is going to be the real improvement is getting some information on capacitors not well understood, and a lot of content will be added, a new article and a new annex in NFPA 70E, and that'll be in Chapter 3. And in Z462, we would anticipate that we would see this information added as well. So talking about Z462 again, just to bring everybody up to speed. So how did we get CSA Z462 in Canada? NFPA and CSA signed a memorandum of understanding in 2005 to harmonize standards for North America, and there was sort of a convergence at the time. There was a rule in the National Electrical Code, Article 110.16, with respect to arc flash labeling on electrical equipment, and that information became aware to members of our Canadian Electrical Code Part 1 Tech Committee, and we were going to have a new rule that wasn't included, which is an arc flash and shock equipment label. So our label includes the word arc shock on it. And then in 2006, that was published in our CE code, but at the time I attended a conference, found out about 70E, and I approached the CSA about, are we doing anything in Canada? It turns out with the MOU that I was not the only one asking about 70E, and they selected it to be the first one harmonized, and the CSA Z462 Workplace Electrical Safety Standard became a new standard for Canada, and a tech committee was constituted based on my inquiries and whatnot. I was asked to be the first vice chair and a voting member, and I've been a voting member ever since. We in fact have our tech committee meetings for our 2021 edition continuing, and we have our web-based meetings next week, again, to continue with our revision and review of the new 2021 edition. So the first edition of Z462 published, dated December 2008, but officially was available January 2009, aligned with the 70 2009 edition. And some of the biggest changes, I think, and the differences are the annexes. So we had decided to add some additional annexes. Some of them have been adopted in 70E, some of them have not. So Annex A, aligning implementation of the standard with occupational health and safety management standards, which is a really important and, in my opinion, not well understood requirement, was added. There is a similar annex, not as detailed in 70E, and one annex that I'm going to highlight is Annex Q equipment labeling. I actually wrote that annex, and it's not included in 70E, and it really would help with some of the problems with equipment labeling that have occurred over the last 10 years. So we have 4th edition, again, 2018, and we're moving to our 5th edition, 2021, for Z462 in parallel with NFPA 70 at this point in time. So technical harmonization This is the last 4 editions of Z462, and we have remained technically harmonized. Again, they look different. They're structured different based on CSA and NFPA's requirements of how they format their documents. And as I indicated, we included some additional annexes, and there'll be minor tweaking changes, but the technical harmonization is still in place. The big change in the blue line in the middle between the standards, it moved to what I say initially was hazard and PPE. And then in 2015, the risk assessment procedure was added. And the 2018 editions, the risk assessment context of the standards was fully integrated. So right from the risk assessment procedure to the shock risk assessment and the arc flash risk assessment, they're what I call true risk assessment requirements. A general risk assessment procedure for a job, and underneath that, for individual work tasks, an arc flash and shock risk assessment. So harmonized, the big change again, and what I really applaud is the move to include risk assessment, which aligns with occupational health and safety management systems globally and risk assessment standards globally. So moving on to the processes, this is a public process, and once, for instance, 70 publishes, within a certain timeline, they open it up again for public comments for the next edition. So the 2024 edition of 70E, after the 2021 edition, it publishes, they will open it up within a certain timeline, and then public can start to provide comments. And it's all done on NFPA's website. So again, I'm going to show some slides just so everybody's aware. Again, based on the polling, not a lot of attendees were completely aware of this. So, and all along, I've encouraged people that I talk to, if you don't like it, put a public comment in, or if you think you've got a better idea, or we need to clarify content, put a public comment in. So this is a snapshot of the website. You navigate there. You do have to create an ID to get access to some of this information, but there's no cost, and then you can access the information. This is the 70E page, and you can see at the bottom the current prior editions, the next edition, tech committee information, and you can ask a technical question as well as of NFPA. So I've just sort of zoomed in on the next edition, and right now, if you go to this website, you can see all of this information. You can view it, you can download it. Again, this is the first edition, the first edition, the second revision draft information, the draft ballot, agendas of meetings, the actual public comment reports. And then really this is, well, what I'm showing now is this is what happens with these public comments. They're formatted. You can see the first comment, you can see the tech committee's review and statement and substantiation. So again, it's fully public accessible. Even the NFPA 70 tech meetings you can attend as a guest. They're open to the public. You have to get permission to show up, but again, it's completely public, wide open process. So specifically the second draft report has been published. It says January 12th, so it's available. And when you load that, you actually can see what NFPA 70 will potentially look like. And then there's a correlation. This is called TerraView. It's a software that NFPA uses, and you can actually go to each chapter and article and view the changes. You can look at the first revisions, the second revisions. It's all there, right? So again, public disclosure. Everything I'm presenting today is available online, and then it's a matter of how you interpret it before it's published. And then if you do some interpretation before it publishes, you better make sure that you follow up with the actual published document. CSA group is a little bit different. It's not as formal. It doesn't have the software tool and the online system, but for Z462 and Annex W, public comments or requests for amendments can be made and submitted to CSA. And then the CSA project manager will receive those, and then the tech committee will review those. So it's the same process, just not as formal and doesn't have a software tool that's used. So the information is not as readily accessible to the public as the NFPA 70E website that I just showed you. So moving into interpretation application, a little sidebar again. So these standards are not adopted into occupational health and safety related legislation in the US or Canada. They're industry accepted best practices, and really I use the word benchmarking that at this point in time, especially in Canada, let alone the US, if you're not using 70 or Z462, your competitors probably are. So it's in your best interest to apply these documents to arc flash and shock hazard management for your company. 70E does have a global perspective and global use. It's used, in my opinion, in other parts of the world, and it's actually adopted in some other parts of the world. So 70E does have a bigger reach. It's been around longer. So Australia, New Zealand, South America, South Africa, Europe, Asia. So again, it is, in my opinion, a global best practice as well for identifying arc flash and shock hazards, risk assessments, policies, practices, procedural requirements, and the tools that are in it specifically to arc flash. So again, due diligence is the employer's basis of due diligence if they choose to. Again, it's not adopted into law. Interpretation is important, and really the employer needs an electrical safety program. So it's really important that they have an electrical safety program. It is a mandatory requirement of 70E and Z462 as well. They are work case-based standards, so work task-based and risk assessment-based. So risk assessment procedures required, and underneath that, you need shock and arc flash risk assessments. Again, those are also independently what I call true risk assessment processes. The 1584.1 in the poll again, and this has been something that I've been communicating via my network or on LinkedIn as well, that not many people know that IEEE 1584.1 was published in 2013 as a complementary guide to the main IEEE 1584. So IEEE 1584 originally published in 2002. In November 2018, it published in its second edition. And then we are in the process of updating 1584.1 with some, in my opinion, minor changes to align with the new IEEE 1584 2018 edition. So I would encourage you to buy IEEE 1584.1 if you are completing arc flash hazard incident energy analysis studies and calculating the arc flash boundary, because it will allow you to do a gap analysis to how you've been doing those studies, and specifically the reports issued. And I have been reviewing some of these reports for my clients, and there's significant concerns I have at times with respect to the content and the quality of the reports. So you could do your own QA/QC against this identified guide and advise your client that your report complies with IEEE 1584.1. It's an amazing additional supplementary document to 1584 that not many electrical engineers completing studies are aware of. So basically, I really encourage you to buy it. It's actually quite affordable. I think it's like $40 US. So, and then audit your existing reports, and I'll talk about labels. 1584 does not stipulate the arc flash and shock equipment label. NFPA 70E and Z462 do. So just again, embellishing on things and giving some information about the differences in 70E and Z462 editions. So what happened is there was a misunderstanding of the application of a hazard risk category number to the incident energy analysis results of an arc flash hazard incident energy analysis study, and that was actually technically incorrect. And most of the reports came out correlating the incident energy value to an HRC 1, 2, 3, or 4, and that's exasperated a misunderstanding in industry about how arc flash PP is actually rated. So in the 2018 editions, if you were not aware, and you might not be aware if you're doing the studies and you're not up to speed on 70 and Z462, it was clarified that when an incident energy analysis is completed, that you do not call up the clothing related to the incident energy analysis results with an HRC number, or now an arc flash PP category number or a level letter. And tables were added in the 2018 edition in 70E table 130.5G and in CSA Z462 table 3 that advises when incident energy analysis method of determining additional protective measures has been completed, that there's two arc rated levels. So there'll be a level 1, 1.2 to 12.0 calories per centimeter squared arc thermal performance value, everyday task wear clothing, and then an arc rated level 2, which would be greater than 12 calories per centimeter squared arc thermal performance value, and that would be an arc flash suit, right? So when you have incident energy analysis studies, you do not call up the clothing in the report or after that with your workers related to your program as a category, an HRC, a level number letter. Basically, I would call it level 1 and level 2, and based on these two tables. These tables were extracted actually from Annex H and brought into the body of the standard. So you cannot call clothing up by an HRC number, CAT number, or level letter. You weren't supposed to, and now it's completely clarified. So there's the tables, just a quick snapshot of the two new tables added in 70E with the two arc rated levels, and the clothing underneath is a shopping list for full body arc flash PPE. Here's some examples. So again, on the left would be the 1.2 to 12. Again, coverall, rubber insulating gloves, leather protectors, provide arc flash protection for the hands, shield, balaclava, canal insert earplugs, clear CSA approved, or again, approved safety glasses. On the right then would be the level 2, the arc flash chute. And by the way, arc flash chutes are available up to 140 calories ATPV. On that note, 40 calories per centimeter squared, again, just an interpretation. That is not a dangerous incident energy level, and PP actually exists. So this was a myth that arc blast pressure correlated to arcing to incident energy when it didn't. Arc blast pressure correlates to arcing fault current as per Dr. Ralph Lee's original research from 1980s, and it's the graph on the side. So if you've never seen this, again, this will allow you to get some education on why 40 calories is not a stop point for energized electrical work. Blast pressure correlates to arcing fault current, and you can see on the graph that it's distance related, and then you can see the arcing fault current go up and cross correlates to a pressure in pounds per square foot. So, and this is actually documented in the IEEE, which is now the 3007 series. It used to be in the yellow book. So this information is available. Moving on with respect to labels. So labels are specified in 70E and Z462 with respect to the content of the label, and they reference the ANSI Z535 standard. And these two labels would be examples of ANSI Z53 compliant labels. And I just wanted to again include this for clarity, interpretation, application briefly before we move into the differences. Recently, unfortunately, I did review a report, and the warning labels, believe it or not, were provided with black warning on orange, red, blue, and green, right? So that's where this information is provided to the end user, the client, and it further exasperates and confuses the client's application of the information with their qualified electrical workers. Now, moving into the public comments, second revision, expected changes for 70E. So again, right now, we're technically harmonized, Z462 to 70E, so we would expect that these changes would be included in Z462, but as I said earlier, I'm advising you that I'm not going to say that that's going to happen. You have to check the published documents from NFPA and the CSA group when they're published to confirm any of this, because it's not gone through formal approval processes. On the screen, one of the points I want to make, and this is important this time around, it's happened in the past, but there's some significant movement of content from articles in 70E or clauses in Z462. So when you see this in the new documents published, you're going to have to realize that things shifted, and then article numbers or clause numbers have changed, and then your navigation of the standard will in turn have to be revised. So that's what's really happening here. The biggest change is some additional reorganization and shuffling of the content in Chapter 1 for 70E, Articles 110, 120, and 130, where Clause 4 and Clause 4.1, 4.2, and 4.3 in Z462. And I really do like what's happening here with the reorganization. So first of all, Chapter 1 definitions. And I'm not going to, the definitions, again, the changes here are quite minor. So it's a lot of wording changes. So these are the definitions where we're seeing some changes. And basically, I've just got in the brackets some brief substantiation. So changes slightly to balaclava, barrier, electrically safe work condition. Of interest, the arc resistant definition, the word switchgear is being substituted with equipment, because there's other equipment that could be arc resistant other than just switchgear. Fault current available, clarifying that that might be different depending on the facility location. Field evaluation, shock hazard, voltage nominal, and working on. Again, voltage nominal, there's some additional notes there related to DC battery voltages for an NEC cross correlation. So that's basically, I think, 8 definitions, slight changes, nothing major. Moving into where the big changes are is 70 Chapter 1, Article 110, and this is this shuffling. Again, this is the shuffling and movement, but I really like what's happened here to further clarify at the front of these documents what the intent is. So there's some movement of the priority from Article 105 into 110, and then the organization of these new articles, Article 110.1, 110.2, 3, 4, and then 110.5 was existing material related to an electrical safety program as a mandatory requirement. But now the introduction is the priority of the standards, a general comment, and here's really what's happening. The intent is communicating elimination as the first priority, right? We want to eliminate hazard exposure, right, to arc flash and shock for a worker, and all workers. This would be electrical or non-electrical if possible. If we cannot establish an electrically safe work condition, then we have to have justification for energized electrical work. And then we also have moved the normal operating condition definition underneath this as well. So we want to have normal operating conditions, and that's a preamble to the risk assessment procedure required when we look at likelihood of occurrence. And then we move into the employer shall have an electrical safety program. So again, I really do like this shift, but it's moving content from Article 120 and Article 130, or Clause 4.2 and 4.3, and that's where you just have to realize that that shift and changes when you're looking there, and well, what happened to that content? It moved, right? It moved. And it will be easy for you to see these changes, again, with the standard NFPA and CSA group notification within their documents of what's changed. So there is a difference between how that notation is between NFPA and CSA. So again, when you see the published standards, you have the ability to understand what's new content, deleted content, again, with respect to the standard itself. So just some specific articles that are being updated. And again, once we get into some of this content, the changes are not substantial. It's either cleanup or a shifting due to some, overriding, directive to get rid of any specific references to another standard. So Article 110.5, they're deleting the specific reference to ANSI Z10, which is Occupational Health and Safety Management standard for the US, and they're pointing to Annex P, which does provide guidance on using 70E with Occupational Health and Safety Management System standards. Again, H1, Article 105, that's generic word changes again. Process to be used is added and removing by the employer. Article 110.5 I1, job safety planning. There's a new annex, modification, Annex J, adding a sample job safety planning checklist. That article, or clause in Z462, says the qualified person shall document a job safety plan, but there was no guidance on what that document looked like. Now there's some guidance provided that's brand new in Annex J. So again, Article 110, the lockout program, there's some clarity that under your electrical safety program, that a lockout tagout program could be included with the electrical safety program, or this would be a separate document, part of the employer's occupational health and safety management system. And you'll find that lockout tagout programs are separate documents, right? And my opinion is they should be. So it just clarified that that's how this could be provided, embedded with the electrical safety program, or a separate document. Article 110.6, now these numbers have shifted, again, with the changing of the numbers, as long as I've captured that. So training requirements, electrical safety training qualified person. It added to the list item that the employer via supervision should annually confirm that the employees are complying with the standard. So again, I call this supervisory level audit of their qualified electrical workers. One that's been very interesting and somewhat controversial is Article 110.6A4. The type of training is now been recognized that web-based electronic training, as long as it's interactive, again, defining what's interactive will be another challenge, but it does recognize that web-based training is valid, which, given our current situation, we're going to see a lot more probably online web-based training. It is widely actually used anyways in the last 5 years or more with respect to occupational health and safety training. So that's a good add. Some wording changes under Article 110.8, test instruments testing. Remove the specific reference to a voltage and just said where an electrical hazard exists. Article 110.9, portable cord and plug connected electrical equipment. It added the words or wet, again, to clarify, conductive or wet work location. The words wet were included in the article content. So that's what's happening here. Public comments come in to further clarify, do some technical fixes, and it just, again, it clarifies it for the user at the end. Now moving into Article 120, only a couple of things I'm going to note here is Article 120.2, lockout tagout principles, lockout tagout procedure. It added a sentence that this procedure shall meet the requirements of, again, overriding regulations. And the OH&S regulations in North America are very stringent and particular with respect to control of hazardous energy. So it's just sort of really indicating that you may have to meet some detailed obligations. And like I said, that is as well documented in occupational health and safety regulations in North America, and I would anticipate globally as well. And then this is a real interesting one here because it pushes to the new capacitor content. So Article 120.4, lockout tagout procedure, the elements of control stored energy. So specific to capacitors, this new article 360, that's brand new, safety related requirements for capacitors, and the brand new Annex R in 70E, working with capacitors, is phenomenal content. Another gap area, and over the years that I've been involved in this and attending the IEEE Electrical Safety Workshop, it's amazing the technical papers that come forward, and then we move that information into standards, and that's what's happened here. There was some technical research done, presentation and paper presented, and then that was added, or public comment was submitted for 70E. So a real game changer there. Some excellent content that I think globally would be significant with respect to capacitors. So Article 120.5, the process for establishing and verifying electrically safe work condition, there was 8 steps here. So that's that hasn't changed, but what's happened is some wording changes. So step 5, some wording changes to clarify, again, non-electrical energy. So mechanical energy, the wording is now changed to block or relieve stored non-electrical energy in devices to the extent the circuit parts cannot be unintentionally energized by devices. In item 7, verify if it's de-energized. Well, again, technical wording changes here. Testing for absence of voltage. That is the correct wording. We want to test for absence, right? So energized and de-energized, sure, but we want to eliminate the hazard, so we do that by ensuring we have absence of voltage. 120.5, just again, the exception number 1 to 7, again, wording changes again, so we're not using this permanently mounted device to test, we're using it to verify absence of voltage. So that's the wording changes here, and I just couldn't facilitate that without showing the example, but it's, again, in this article or clause in Z462, you'll be aware of it. The wording's changed because the device is not testing for the voltage value, it's testing that there's an absence of voltage. Moving into Article 130 again, so there's the renumbering here, and this is where some of the content with respect to justification for energized work was moved forward into Article 110 or Clause 4.1 in Z462. So then there was public comment to revise sort of the general and the introduction here, which again I really like because it frames the content and positions the user of what you're going to see in the remainder of this article or clause 4.3 for Z462. So Article 130 covers requirements for work involving electrical hazards, work practices, assessments, precautions, and procedures when an electrically safe work condition cannot be established. It then says we want to use work practice and safeguard employee from injury when exposed to electrical hazards. If the energized conductor circuit parts equal to or greater than 50 volts, we have that as 30 volts in Canada, so there's another difference. It's based on justification, and then the following requirements shall apply. So this is new content that only qualified persons should perform the energized work, that you may need an energized electrical work permit, and I want to note that there's exemptions. There's exemptions to the permit, and then again, when you do work energized, you shall complete and document a shock risk assessment, and you shall complete and document an arc flash risk assessment. The last bullet again, to clarify this whole issue about incident energy analysis versus the arc flash PP category table method, all of Article 130 or all of Clause 4.3 in Z462 applies whether you're using one of these two methods to determine additional protective measures for a work task arc flash risk assessment. That is all that we're doing with the incident energy analysis, is we're providing electrical hazard data, the incident energy and the arc flash boundary, that's then applied by the qualified person when they complete their arc flash risk assessment. Article 130.5G, incident energy analysis, there's a list item added to clarify with respect to outerwear worn for weather, cold, rain, and that when that outerwear is worn, that outerwear doesn't have to be equal to or greater to the incident energy when incident energy is calculated, but it has to be arc-rated clothing, right? So we'd have, say, the primary arc-rated clothing that's going to be equal to or greater than the incident energy from the study and on the equipment label, and over top of that, we'll have other clothing to protect you from cold, rain, etc. So again, just moving on here, 130.7C1, there's a new note added, again, clarifying again, if we have an incident energy that's greater than the available PP, and this only relates to the absence of voltage testing, only that it's suggesting some other methods where the work task can be completed when the incident energy is higher than the available clothing, the arc flash PP that the worker has. So these are, again, new content, 4 things. Use a non-contact proximity test instrument on the secondary side of the transformer before using a contact test instrument. If the equipment design allows it, observe visible disconnect, increase the working distance, because when you increase the working distance, the incident energy drops off significantly. Or item 4, which is unfortunately a longer term consideration, consider system design options to reduce the incident energy. So that involves engineering safety by design and reviewing incident energy reduction methods. And there's quite a few of those available that have evolved from options available from equipment manufacturers. So again, if the incident energy is greater than the available arc flash PPE, only for absence of voltage testing, here's some suggested items that the employer could consider to then have the work completed. I'm not going to cover any Chapter 2 or Clause 5 changes. I think there wasn't a lot, actually. I'm not going to cover those. And then I'm just briefly going to highlight in Chapter 3, safety requirements for special equipment. And I think this might have been the majority, or what I would, in my opinion, classify the most important changes. For Article 320, requirements related to batteries and battery rooms, safety procedures, general safety, battery risk assessments. There's actually a flow chart for battery risk assessment that's been added to Annex F. And it's an excellent visual tool with respect to looking at doing an electrical hazard risk assessment, hazard ID for batteries. And then here I said earlier, this is really the game changer and it's really valuable globally. Again, I keep seeing things, come out from our review of these hazards in North America and specifically the US. So we have a new Article 360, which will be anticipated to be a new Clause 4.3 item in Z462, completely new article, laboratory research and public comment, as I said, and this material was presented at the IEEE Electrical Safety Workshop a couple years ago. And the new Annex R then expands and embellishes on it. Annex R, I can't remember how many pages it is, but it's amazing. It's exhaustive content for capacitors that we've never seen before. And so again, globally, I think this information will be valuable with respect to our use of capacitors, which are readily utilized, again, in our power distribution system. So really excellent content. And just the annexes, I'm quickly going to highlight because of the IEEE discussion, that Annex D, all the formulas have been deleted from the 2002 edition, all that content, and it's been updated or anticipated to be updated to reference the 2018 edition, but it won't provide the formulas. And that's a good thing because these standards change and the formulas don't match. And really, an engineer doing the studies should have and purchase a copy of IEEE 1584 and have that to use to substantiate their calculations and the information they put in their reports in the study. And then Annex J is where the job safety planning checklist has been added. And then that Annex R will be the new annex working with capacitors. So really, I think the standard, when it's published, and purchasing a copy of either standard will be worth its weight in gold just for the capacitor information that's being added. So Z462 expected changes. I mentioned earlier, we are technically harmonized at this point in time, and the goal is to remain technically harmonized. That has always been our plan and directive. We are taking a different look on Table 6A because IEEE 1584 published after 70E's first revision, and therefore it couldn't be considered for a public comment, but we do have the latitude in CSA and Z462, so we're reviewing some potential opportunities there. We will have some new annexes potentially, switching and isolation, which I think is a good one for high voltage equipment, and an annex with some additional information on temporary protected grounds. So this is all, again, potential changes and whatnot. And then we are reviewing some of the other annexes outside of 70E and adding some additional content or clarification. And I mentioned Annex Q, equipment labeling. That's going to be updated because we can have the employer and a large industrial supervised site provide the arc flash information with other methods than equipment labeling. Results tables could be provided. And then we're updating some content, minor updates to human performance. So I haven't listed all the annexes and the potential changes in Z462, but again, we're trying to maintain technical harmonization. And yeah, so just looking at time, I think I'm doing pretty good here, and I'm just going to conclude, and then we'll open it up for some questions. So in conclusion, 70 and Z462 follow formal processes for public input or request for amendment. And I did mention that obviously NFPA's process is a lot more mature. It's digital, it's online. Z462 still, obviously, like I said, has a public amendment process that's available. It's just not as automated and online as NFPA's process for their standards. when these standards are published, the users have to interpret them, and there's been, again, some misinterpretation and misinformation, which I highlighted, related to the reports and the HRC category numbers and whatnot. So it's, again, this struggle between the user having information and coming from different sources in their interpretation. And again, we want to make sure that we have effective implementation and due diligence to the overriding legislation, occupational health and legislation. And globally, this is really what we want to do, is we want to make sure we use these standards, again, like I said, to the benefit of reducing, well, eliminating exposure to arc flash and shock hazards, or reducing risk to as low as reasonably practicable when energized electrical work is completed. We need energized electrical work to be completed by qualified persons. And in Canada, US, and globally, it's trying to define that qualified person, which is a prerequisite and definitely a significant requirement to risk with respect to lake of occurrence. Again, and then energized work, we will not be able to eliminate it. We need to isolate electrical equipment, test for absence. We need to do diagnosis and troubleshooting. We want to get rid of the energized repair and alteration, if at all possible. As I said, the good news is the 2021 editions, the quantity and significant changes is substantially reduced. Like, I can't remember how many public comments in 70E for the last 4 years when I attended the meetings. It was like 400, 500, might have been as high as 600 public comments. I think there still was, a substantial number of public comments, 300 or 400, but I think a lot of them, there's overlap as well when that happens. And as I presented today, the changes I've highlighted are, in my opinion, not significant from a technical perspective, but reorganizational clarity. And then the big game changer is the capacitor content that's added. So when published, the employer needs to review the published changes, or anybody that's a participant in this webinar. Again, I'm providing my personal and professional interpretation of this information and presenting it based on what's publicly available. So make sure that you buy copies of 70E or Z462. And at that point, if you do want official interpretation, you can go to NFPA or the CSA group. And I showed you that online. There's even the online request on the NFPA website. So as far as end users, every time a new standard publishes, they've got to update their electrical safety program. And then they should move to providing updated training, right, to advise the employees, the qualified persons or others, of the changes. And then I recommend that really the real thing, the real item here that employers need to do is train their employees on what their specific policies, practices, and procedural requirements are. So that the employer needs to train on their electrical safety program. And I could embellish on that further, but I'm looking at the clock and we're running out of time. So lastly, I guess, Jim, at this point, I'd like to open up to questions. And so I'll hand the wheel back to Jim, and I'm going to open up the questions myself.
Yeah, we
Jim,
have.
Is there any questions?
Yeah, a few questions. Yeah, some interesting ones. In fact, I wanted to thank you for that information that you showed regarding the Ralph Lee data on the pressure wave. So that's my first exposure to it.
Yeah, well, and again, like I said, is it's putting all these puzzle pieces together, and not a lot of consulting engineers, necessarily know, because it's not up to the software vendor to tell them all of the details. You gotta look broader than that, and start with IEEE 1584, but then the whole thing with 40 calories. Really, that research done by Dr. Ralph Lee, actually, just a plug for Canada. He's from Edmonton, Alberta, Canada. He didn't do a good job of spreading the word, right? And so that is still the latest information on pressure. The IEEE 1584 tech committee and the research project, it just didn't get around to the pressure question. It will. It's still on the to-do list. So there's going to be more research coming on pressure, on single phase arcing faults and arc flash. So yeah, that's the correlation is to arcing fault current.
So one of the first questions came from a visitor from Mexico. He says, do you know the relationship between NFPA 70E with the Mexican standards?
So the Mexican standards. So I'm aware that there's a Mexican document, and again, I know I've seen it a couple times. I haven't immersed in it myself to it, but my opinion would be that the Mexican documentation, I think your best bet would be to say, hey, we're going to use this U.S. standard, NFPA 70E is actually published in is it published in Spanish? I think it's available in Spanish and in Portuguese as well. So if a country creates their own sort of overriding standards or, you know, above and beyond the regulations, I would tell them that do not discount 70E, right? It's not that much money to buy it, and my opinion, I've done presentations and attended conferences globally, and I find countries trying to reinvent the wheel, and it's sad that we just don't have a better way of sharing these standards across jurisdictions. But anybody that's online globally, I encourage you to, look at what's going on in your country, Australia, Europe, Mexico, South America, and whatever is happening, I always say, hey, we're also looking at this US standard 70E, right? It's just good due diligence, right? So, and the other documents I've seen in Mexico and Australia, you know, they're trying to do the same thing, but do it different, right? So, and again, use 70E in reference to anything that might be, you know, being created or has been published in your country.
So here's a question from Alexander. He's asking, does the limit of 40 calories per square centimeter still applicable with Table 3?
Well, no, because like Table 135G or Table 3 for Z462, the 40 calories is immaterial to that. What I was trying to highlight is the misunderstanding about arc blast pressure, and there was some notes in 70E and Z462 that indicated, you know, it said if the incident energy is greater than 40 cals, it says, I can't even remember the wording, you know, additional oversights required. It didn't substantiate it, and those notes were deleted because they were never substantiated, right? So don't mix up 40 calories with the range of clothing that can be applied based on risk assessment. The way risk assessment works is we're trying to evaluate potential severity of injury or damage to health to like of occurrence. And when you do a risk assessment, it proves that we can use an arc flash suit up to 140 cals because there's one available, and it does the same thing as an 8.7 calorie coverall does. It reduces the burn probability of injury to 50% probability of a secondary burn. So 40 cals was a cutoff because it correlated HRC4. The HRC4 was embedded in the studies and the results table, and then it just said danger, no PPE exists. Well, it isn't dangerous because the PPE at 40 cals or 140 or 8.7 performs the same for the burn injury probability, secondary burn injury, right? So I hope that answered the question. And offline, I'm more than willing to talk to anybody that wants to talk about that and provide further discussion and substantiation.
Here's another question. Says, why is it incorrect to provide PPE description on the arc flash label? Because it's a convenience to the electrician.
So I've been an advocate since I started getting into this that electrical safety programs shall be developed and implemented by the employer, and the label shouldn't stipulate the clothing. The electrical safety program should stipulate the arc flash and shock PPE tools and equipment that the employer is going to specify and procure and provide to their qualified electrical workers, the qualified person / electrician, right? So, and again, when the engineer pumps out these labels from the software, it does allow them to put descriptive clothing on there. Well, if I was the client, I'd say, hey, I don't want that because you're not specifying the PPE. I'm the employer, I am. And I also talk to electrical engineers doing the reports. You got to limit your liability here too, right? You're paid some money for sure, but your errors and emissions insurance is expensive. So in your reports and the labels you provide to the client, don't provide information that you can't substantiate that the employer is going to do. Don't provide any direction that you may not be able to, again, substantiate. Heaven forbid if you're ever called to substantiate it during an incident investigation, right? So there's the other reason why the engineers doing the study shouldn't put more information on the labels or in their report related to PPE, because you're doing a study to calculate the incident energy at a working distance and the arc flash boundary. That's the information you provide to the client. They say, hey, we want some information on PPE, tell them to look to 70E or Z462, even if they want it on the label. All I would recommend on the label is, it says for PPE requirements, see the company's electrical safety program or 70E or Z462.
Okay. Next question says, is there some standard to do a battery risk assessment?
Ooh, well, guess what? 70E and Z462, they are the standards, right? So they have existing content, right, in Chapter 3 and then Clause 6. And then now what's happening is this flow chart that I'm alluding to, right? It's going to be added. I think it's going to be a no-brainer that it'll get approved. So when the new 70 publishes, I think this battery risk assessment flow chart will be beneficial to the users. Right now, I know UPS systems and specifically batteries, not a lot of work's been done on them with respect to instant energy calculations for arc flash. So I think this new flow chart's going to provide some guidance, right? That batteries, again, shock, arc flash, at what voltage, DC voltage we have an arcing fault, sustainability, and then you obviously have the overriding chemical hazard with batteries as well. So that's coming. So again, buy a new version of 70E or Z462 and get that additional battery assessment content when it publishes.
Okay, the next one. Do I need a certification by NFPA 70E to conduct an arc flash assessment?
Well, again, I'm just sort of interpreting that question. There's no certification for any training. There's no certifying body for arc flash and shock training. There's a whole bunch of people providing it. It's the employer's obligation to make sure that the training they receive is compliant. So there's no certification related to 70E to do an arc flash risk assessment. Again, the employer's electrical safety program should include hazard identification, risk assessment, and then the employer would say that when a qualified person is potentially exposed to arc flash, we provide them information, and then that qualified person, they perform the arc flash risk assessment, which means they get the information off a label or results table or using the arc flash P category method, and then they determine additional protective measures. The worker exposed then decides what arc flash PP they need, right, to do the work with, again, accepting some residual risk, again, related to the performance of the arc flash PP. So I'm hoping that I sort of answered that question, right, based on what I can read there.
Mm-hmm. And then there's a follow-up. Where is the indicator, or what is the indicator in the threshold between the 40 calorie per square centimeter and a normal warning label?
So here's my opinion, that arc flash PP, an arc flash suit, is available at 140 calories per centimeter squared arc thermal performance value. So the danger label should be at 140.1 calories per centimeter squared, because when you do a risk assessment, it will validate that if required, you can apply that 140 cal arc flash suit to the work task, and you are managing the risk of potential severity of injury or damage to health. Because remember, I said that no matter what, if the PP is 8.7 calories per centimeter squared ATV or 140, the 50% probability burn injury is the same. So that's the demarc between warning and danger that I now recommend. This is my opinion, is we have warning used up to 140.0 calories, and danger is 140.1 or greater.
And then it looks like the last question is, if you're an engineer working for a utility company, is it okay to put PPE on the label since the company you are working for owns all the assets?
So if you're an engineer working for utility, is it okay to put PPE on labels since the company you're working for owns all the assets? Again, I'm trying to interpret these questions. So I don't encourage that we prescriptively put the PP on a label, right? The label should be the arc flash hazard information. The PPE is specified and procured by the employer through the information and electrical safety program. Again, that's my opinion. That's my interpretation of 70 and Z462. Ultimately, an employer can do whatever they want with respect to how they present the arc flash and shock data on an equipment label, right? But as well, I mentioned that in the 2018 editions, there's the employer for a large supervised industrial site can provide the information, the hazard information, via results table or other information, and then the worker is given the PP. They know what they have available to select against that hazard information.
Terry, it looks like we're out of time, and I very much appreciate the presentation, and I always look forward to your take on things. And thank you very much for contributing.
Jim, again, I want to just say thank you to EasyPower and yourself for moderating today. And I really do, again, appreciate being allowed to, offer my opinions and my interpretation. I'm just trying to make sure we get arc flash right. That's sort of my quote. So thank you again, Jim, and thank you, EasyPower, and thank you for everybody attending. And if there's any questions offline, again, you can please get back to me through Jim, and I'll gladly provide you a response.
All right, stay safe. Talk to you later.